Welcome to Earth Science, everybody. I'm going to show you a quarter. We all know what a quarter is, right? And think about what happens size-wise to this quarter as I move it closer to the camera and further from the camera. Closer to the camera and further from the camera. What happens to its size? Now, if you're really thinking, does its size actually change? It's a quarter, right? It's not a magic quarter, it's just a plain old quarter. So if I bring it closer and further from the camera, does it really get bigger? No. There you go. I answered the first one for you. Answer it. But does it appear the same size? And that's going to be the thing today. We're going to be thinking about the idea of apparent size and noticing that the sun does not have the same apparent size throughout the course of the year. There's times where it appears a little bit larger, there's times where it appears a little bit smaller. So, what's the deal with that? Thinking of these examples, like answer this number 3 one right here as well. If this guy were to bring that weight closer to his face, what would it look like from his perspective? The weight itself, of course, is not going to actually change size, but its apparent size. What happens? And then read and answer this one before you move on. Press pause if you need to. And tell me what you think to get us warmed up. Okay? I'm going to pause real quick to let you do that. Okay, so we're going to plot, and this might look like a lot, but trust me, this lab generally goes very easily for people. Once you see how it works, people whip right through all these, no problem. We're going to mark just a couple of specific dates on it, and no big deal. The one trick to it all is the way that we measure the angular apparent size of the sun. Again, not how big it really is, but how big it appears from Earth on these different dates. You don't have to write this over here, but just to like explain it. If you've been in math class and you've done like, this is an angle of blah, blah, blah number of degrees, it's like that. Only what happens is that you can break down degrees into smaller amounts. Now, if life were easy here in neuroscience, because we're going to have to deal with this a couple of times, and it was like 0.5 degrees, that'd be like the decimal system you guys are all used to. But what happens here is that we break each degree down into 60 minutes. That's what that little tick mark means. And then each minute into 60 seconds. Now, you don't really have to understand that to be able to fight through this lab because all the numbers are pretty close. They're all right on this chart. It's all pretty easy. Once you do like your first couple, you'll see how they go. When people like take a few minutes with the first 2-3 points, and it's like no problem. Okay, I promise. X-axis, all the dates match exactly what the dates are here, so that's no sweats. Y-axis being the angular size in degrees, minutes, seconds. Now, really, it's like 0 degrees, 31 minutes, and 20 seconds. So this is like the angular size of the sun as it's high in the sky appears to be less than 1 degree as an angle from like the bottom of the sun to the top of the sun. Okay. So each one of these little boxes here is going to go by 5 minutes. So again, don't let it panic you. Basically, like that line right there, 32, all the 31s are down there, all the 32s are up there, like 31 to 32, no big deal, right? Each one of these boxes is 5 minutes. So 20, 25, 30, 35, 40. I'm sorry, I should have said seconds. So maybe I'll write a few in here. Maybe not a bad idea for you folks to give that a try. So that's like 31:45, 31:50, 31:55, and then 31:60. Excuse me, kind of like time, like when you get to 60 seconds, you go to the next minute, right? So 31:60 is really 32:0. And then it like starts over. So 32:05, 32:10, 32:15, 32:20, 25:30, 35:40. If you want to write them all, you can go for it. If you don't write any of them because it makes sense to you, that's fine with me too. So let's do one. Again, here in Cami, doing dots, I'm recommending going to somewhere around the size 6. Pick a color. And you are going to have to make a dot later. That will be a different color, but we'll get there. So January 1st is 32:32. So January 1st right there, 32:32. So there's 32:20, 25, 30, 35. So 32 is probably right about there. Didn't change color, did it? That might even be a little big, maybe 4. because I want those other dots you're going to make to eventually stand out. Yeah, I like that. Let's go to size 4. All right. That's it. Do that. January 10th, 32, also 32, 32. There we go. That's easy. Boom. Okay, you'll get the hang of it. It'll start going down and coming back up. So the things to keep in mind as you do it, if we're high on this chart, that means it appears large. So what does that mean in terms of where it is? Closer to us or further from us? When it's low on this chart, it appears small. So where does that mean where it is? All right. If you keep that in mind, you'll bang right through these questions. All right. And maybe find a surprise about when the sun is actually closest to us. It may feel backwards from what you think, but you will find that out. Do that graph. Step 2 is just to make another big dot, pick a different color, make a big dot on those 2 dates. That's just to help us out a little bit for the questions. You'll be good. Shouldn't be too bad. Good luck, folks. Thanks for tuning in.